The purpose of this video is to introduce you to some of the Venn diagrams notation and also some of the pictorial representations. Venn diagrams always start with a box which defines the group. This is U, which is the universal set, and it often has circles inside of it. This would be the group of numbers or the set of things A, and this would be the set of things B. You'll notice that sometimes items sit in both of the groups. So here's an example. Imagine here's the set of things A, and we'll say A is all the multiples of 3. So we'll have 3, 6, 9, etc. Now imagine that B was all the even numbers. You'd have 2, 4. Now 6 is an example of a number which sits in both. So 6 would come out of here and it would sit in there. So here we have the group A and the group B, and anything which sits to both groups would sit in the middle. It's called the intersection. Here you can see some notation. It says N brackets A. N stands for the number of items that are in that group A. So if I asked you how many items are in the set A, you could say there's 1, 2, 3 items. So the answer to that would be 3. If I asked you the number of A intersection B, that would be how many items sit in the middle of groups A and B, which would be 1. Quite often we need to understand the difference between the terminology and what happens on the Venn diagram. So here what we're going to do is we're going to look at how do we refer to what we mean by shading a diagram. So this means the intersection of A and B. And if I was asking you to shade the intersection between A and B, obviously you'd shade this bit in here. Here we have a new symbol. This is called the union. Union means all of. So this means all of the things in A and all of the things in C. So again, if we were translating that to a diagram, we wanted to shade all of A, the intersection, and also all of C. And here again we have a new symbol. This means subset. So in this case we have C is a subset of A. It means that C sits within inside of the bigger circle A. If we were looking at something like shading A, then we'd shade all of A, and in doing so we would shade all of C. If we only wanted to shade C, obviously we would just shade C. And if we just shaded C, this is what we'd do. So imagine that A was the group of all cars and C was all the green cars. By shading C, we would have shaded all the green cars. Here we have a new symbol, a dash. Dash stands for not. So if I was asking you to shade everything that was not A, clearly we wouldn't shade A and we'd shade everything outside of it. So this is not A. Everything else just builds upon these theories. So let's say A union B dash. A union B means all of A and all of B. The dash means not. So it's all of the things that are not in A and they are not in B. So therefore I would be shading all of the outside. Okay, so here's a couple of bits of notation. Can you draw some of the Venn diagrams? I will draw them shortly and you can check them. So the first one is not A, intersection with B. The second one is A union not B. And the third one is A, intersection with B, intersection with C. So you can have more than two things that combine together. Okay, so here we go. This is not A, intersection with B. So if we're drawing our Venn diagram, we draw our box, we draw A, and we draw B. Here's A, here's B. Always remember to label each one. So we're looking at the intersection of not A and where that overlaps with B. So all of this is not A, and all of this is B. So the overlap between not A This is all not A. And B is the bits which are jagged, this area here. So that is the overlap of not A and B. And showing it more clearly on one diagram, it's there. Okay, so here's the next one. A union B dash, all of A and not B. So if we start with our Venn diagram again, and we'll go A, and we'll go B. This time it's all of A, so all of A is important, all of it, including the intersection because it's part of A, and not B. So everything which is definitely not B. And there you have the diagram. Essentially it's the whole of the A circle and everything on the outside. And finally, we have this one, 3 different intersecting circles. A, intersection B, intersection C. So we need a pretty big Venn diagram now. We're going to have A, we'll have B, and we'll have C. Here's A, here's B, here's C. So we're looking at the overlap of A. So it's all of A. Let me get my pen. So it's all of A, all of B, and all of C. And the bit where they all overlap is just here in the middle.